We need to determine how many of these 5 molecules are polar. We are going to have to make Lewis structures, partial charges, and bond dipoles first. The net molecular dipole will show whether the molecules are polar or nonpolar. If there is a net molecular dipole, the molecule is polar. If there isn't, the molecule is nonpolar. To make Lewis structures, find the number of valence electrons in each atom and add them all together. This molecule has 24 electrons. Make single bonds between each atom and then begin to add electrons to the outer atoms, remembering to count each bond as 2 electrons. Make sure each atom has a full octet, and if there's any leftover electrons, add them to the center atom. This molecule has resonance because sulfur doesn't have an octet. You can add an extra bond shared equally in 3 places. To find partial charges, see which atom is the most electronegative. That atom will hold the partial negative charge. The bond dipoles point from the center least electronegative atom out to the most electronegative. The greater the difference in electronegativities, the longer the dipole. This molecule has 3 bond dipoles in equal directions, causing there not to be a net dipole because the bond dipoles cancel, so the molecule is nonpolar. To position the Lewis structure, you put the least electronegative atom in the center. Fluorine goes on the outside because it is the most electronegative. This atom has 20 valence electrons, and you start by forming octets on the outermost atoms. Fluorine never forms double bonds and already has an octet, and oxygen likes to form 2 bonds, so this is good. The bond dipoles are equal, pointing towards fluorine, but the molecular geometry is bent because there are 2 unpaired electron domains and 2 paired electron domains on the central atom. This causes the net molecular dipole to point down. This means that the molecule is polar. Chlorine is under fluorine in the periodic table and is the 3rd most electronegative atom, giving it a partial negative charge, and beryllium a partial positive charge. Chlorine does not like double bonds, and beryllium often doesn't have an octet, so this is a good Lewis structure. The bond dipoles point from beryllium to chlorine. The molecular geometry is linear, causing the bond dipoles to cancel, meaning there is no net molecular dipole, and this is a nonpolar molecule. Chlorine is the more electronegative atom of the 2, so it goes on the outside. This molecule has 32 valence electrons with none left over after making octets. Again, chlorine is the 3rd most electronegative atom, giving it a partial negative charge, and carbon a partial positive charge. The bond dipoles are all equal in equal directions from carbon to chlorine, causing them to cancel, meaning there is no net molecular dipole, and this is a non-polar molecule. Lastly, we have O3. This molecule has 2 possible equal Lewis structures, meaning there is resonance. In the resonance structure, a bond is shared in 2 places, causing there to be no partial charges and no dipole moments, since it's all the same atom. Since there's no dipole moments, there is no net molecular dipole, causing the molecule to be nonpolar. To answer the question, how many of these molecules are polar, there's only 1. Some common mistakes include not knowing which molecules do not form octets, like beryllium in this atom, not knowing which molecules can experience expanded valence, adding the valence electrons incorrectly, not knowing which direction the dipoles point, causing them to be incorrect, and not knowing the trends in electronegativity on the periodic table.